JavaScript has come a long way since it was created. It was initially written as a way to make the Netscape browser more interactive, more specifically to interact with the Document Object Model, or DOM, that is, written in HTML. Back then, the capabilities of what you could do on the web were limited and still hard to pull off. My mom told me a story about how she hired her very competent brother to make her business's website interactive. The year was 1997. My uncle was tasked to implement some seemingly basic features like a drop-down menu and dynamic styling. After weeks of banging his head against the wall, he came back to my mom very excited of his sole accomplishment. He made an umbrella go from blue to red on mouseover. Modern-day JavaScript developers now can build robust web apps, create 3D games, and even write a server entirely in JavaScript with just a few lines of code. So how did we get here? JavaScript was created by Brendan Eich. Brendan was hired by Netscape and given the task to make HTML interactive. Netscape had their own preconceived notions as to how to accomplish this. They wanted to appeal to two audiences: enterprise folk who needed a robust language to do heavy lifting tasks, and the designers who needed an easy-to-use scripting language for simple interactions. Brendan was given a small window of time to create this language. In that short amount of time, Brendan created Mocha. Mocha was later renamed to JavaScript to solidify its relationship to Java in the browser. JavaScript was designed to look a lot like Java, but had some key differing language attributes. These attributes are that it is dynamically typed and interpreted in the browser. Functions are first-class citizens. It's weakly typed, and it uses a prototype-based object model. JavaScript was designed to be dynamically typed, as most scripting languages are. This means at runtime we are evaluating the type of a variable. While this can lead to developers writing accidentally buggy code, it also gives developers more freedoms they wouldn't have in a statically typed language. JavaScript is weakly typed, meaning we can apply operations on different types and JavaScript will decide how it is interpreted. JavaScript's implementation of how it handles operations on types leads to some unexpected behaviors that throw many developers for a loop. It's important to point out that JavaScript is also completely backwards compatible, meaning these quirks will never change. It's best to use some sort of linter in your workflow that disables you from ever using keywords like var. Functions are treated as first-class citizens in JavaScript. We can store functions anywhere we can store a variable. We can pass a function as an argument to another function, and we can return a function from a function. This all paves the way to some cool functional programming concepts like map, filter, and reduce that are built into modern-day JavaScript. In languages like Java or C++, there's this notion of classes and instances. We call these languages class-based. In a class-based object model, classes describe all of the properties that define what an object would make up. Instances are the instantiations of a class and have the exact properties of its parent class. JavaScript is a prototype-based language, meaning it does not make this distinction between class and instance. Rather, JavaScript uses prototypes. Prototypes are weird, so it's best to just show an example. To first understand objects and prototypes, we have to understand the keyword this. The this keyword refers to the object that is executing in the current context. At the top level, this refers to window if JavaScript is running in a browser, or global if it is running in Node. In this first example, this object's function b returns this.a. The this keyword executes in the object's context, and we get back the expected result of some value. Here, this function is setting the property this.model. If we console.log, within the function, we see that this.model is being set. However, if we log the Android variable, we'll see that it's undefined. So what is the function phone setting this of? Well, if we return the functions this, we'll see that this.model is actually being set on the global object. We can specify the new keyword to create a new generic object. This newly created object is passed to the phone function as the this variable. Now we can start to understand prototypes and prototype chaining. Here we are creating a hierarchy where human is at the top, then Canadian and American stem from human, and finally Kentuckian stems from American. The Kieran object is an American and a Kentuckian. Notice how I didn't define species in the Kentucky function, yet we still get Homo sapien when we print Kieran.species. When we get the property names of Kieran, we only see the properties defined in the Kentuckian function. So how did we get the value of species? When JavaScript can't find a property on an object, it looks up the object's prototype chain. Kieran's parent prototype is American. If we look up Kieran's parent's prototype, we'll see the properties from state. Finally, the American's prototype has the species property on it. So we return that property's value. What if I want to inherit from multiple classes? It's complicated, but JavaScript doesn't support multiple inheritance. But we can fake this multiple inheritance by calling multiple constructor functions within a constructor function. Here, I create a new object, Steve, and I can see that he is a dual citizen. However, he is not an American or Canadian. But by calling the constructor functions this.country1 and this.country2, we can set the properties from province and from state. We can use the class keyword in JavaScript, but it is essentially syntactic sugar around the prototype-based model that we saw above. Finally, let's look at two implementations of the function that determines if a number is prime. This first example looks a lot like how you would see a prime finder being created across many languages. We use a for loop and check each index from the number 2 to right before what the variable value is to see if value has any denominators that result in a 0 remainder. If there are none, we check to ensure that value is a number greater than 1. This type of function is called a function declaration. Declaring a function in this way allows me to call the function before it is written in the JavaScript code. This is because it is being hoisted to the top of its scope. In the second example, we'll look at some features introduced in recent versions of JavaScript. First off, we are using a function as a value of the variable isPrime2. Const refers to isPrime2 being immutable. Function expressions disallow hoisting, so calling isPrime2 before it is declared will throw an error. In the first line of this function, we are ensuring that the value is greater than 2. Then, we come to our next new JavaScript feature. This is what's called a spread operator. The spread operator was introduced not only to speed up operations like concat, but it also enforces immutability. Next, we use another feature built into JavaScript that aims to progress the usage of functional programming in the language. With this find function, we are not mutating state of some index variable. We instead are passing find, another function which returns a boolean. Indices.find returns the first item in the list indices that meets the boolean condition. We could also write the block of code like this. Finally, we coerce the denominator into a boolean in return. Modern day JavaScript is robust. We can write JavaScript that is bundled up as a website or a native app. These apps can then talk to some server that is running a JavaScript runtime like Node or Deno. In researching this class project, I used a variety of resources on the web. Many of the articles are linked down below. The main three I pulled from were a brief history of JavaScript by Auth0, Fireship's YouTube course on JavaScript, and the Mozilla JavaScript documentation. Thank you.